Hi, and welcome to a video where I'm going to show you how to use Desmos.com as a graphing tool to check our algebra. So let's just say I'm given this rational expression and I'm asking you to simplify this. And we will do this within a limit in a calculus problem, or maybe you've already seen that. But let's work through how to simplify it. So let's first look at this correctly, and then I'll show you the common error and then also how Desmos can help you identify that you have made an error. So if I want to put this in factored form, I know that x plus 3 probably is a factor of that numerator because that numerator is in fact a sum of cubes. It is x cubed, right? That's what I'm cubing to get x cubed, and it is 3 cubed. So it's the sum of cubes. So let's say I can't remember how to factor it. Well, I can use synthetic division to help me put this in factored form. I'm going to divide by -3 since that's the solution of the x plus 3 factor when set equal to 0. And then my numerator is 1x cubed, 0x squared, 0x plus 27. Just don't forget your zeros when you're using synthetic division. It has to be perfect descending order. So the way synthetic division worked was we carried down our first value, and then this -3 was our multiplier. So 1 times -3 is -3, and then we add down. -3 times -3 is +9, add down. 9 times -3 is -27, add down, and the 0 is our remainder. That means that that divides in evenly, or -3 is a solution, which means x plus 3 is a factor. And the other factor is right here, which is that quadratic. So my rewrite of this rational expression would be the factor x plus 3 times this quadratic that I figured out from synthetic division, x squared minus 3x plus 9, and it's all over x plus 3. Now some of you might have said, yeah, I got that without using synthetic division, and maybe that's because you memorized the sum and difference of cubes formula to how to get it in factored form. That's great, but for the rest of us that maybe haven't memorized that formula or can't remember it, synthetic division will figure it out for us. Then I believe these factors of x plus 3 will divide to 1, and that leaves me with a quadratic x squared minus 3x plus 9. I've rewritten this original expression, and I'm going to make sure that this step is equivalent as well as the final answer being equivalent. Okay, so I'm going to open Desmos.com, which is our online graphing tool. Okay, so here's Desmos.com. I'm going to click on Open Graphing Calculator. So in this first line here, I'm going to title this f of x, and I'm going to type in my original. So I'm just using my keyboard. I'm going to use that fraction or division symbol, which is right next to my right shift key, and I'm going to type in x to the third plus 27 all over x plus 3. And I don't know if you noticed, but it was actually graphing it as I was typing this in. I'm not going to log in, so I'm going to click out of that. You can, and you can save some of these graphs as well. So f of x, I can now use my fingers. If I have a touch screen, I can use my fingers to zoom in and zoom out, and I can see that this graph is the red curve because that's what it's showing me off to the left here. If I don't have a touch screen, I can also use my mouse. You hold it and you can like left click, hold it down, and you can move the graph wherever you would like. You can also use your scroll. If you have in the middle of your mouse, you're scrolling, I can use that. Or I can also go up to the top right-hand corner where it says graph settings, and I can manually change my x and y axis here, as well as any steps, which are how it's going to count, just like I would do on my graphing calculator. So maybe I want to go x is -5 to x is 8, just kind of making up a window here. Y-axis, maybe we'll go -10 to 30. And I don't know if you saw, but as I was changing each of these values, it's changing and moving my graph around. So I can go back in there if I wanted to, change this to maybe y equals 35, and I can see it immediately change. Click back on the graph, and that graph settings menu goes away. Okay, if I think that this is equivalent to what we wrote, g of x equals, I'm going to first just put the factored form of that fraction. So I'm going to first just say, is this equivalent to the quantity x plus 3 times the quantity x squared minus 3x plus 9, and it was all over, and you notice it's not graphing it because it's waiting for me to put something in my denominator, x plus 3. And now here's the benefit. I can see that my red graph and my blue graph trace each other. So when you click on the color, which is on the far left side of your screen, it shows you what color it's graphing that g of x graph. It's graphing it as blue, so I can click this on and off and see that it is tracing my original red graph, so I do know that these are equivalent. Further, we divided that factor of x plus 3 out, so I'll just put over 1, and I can see that this also traces. Now, if we wanted to evaluate this numerically, this is also something that's kind of neat. I can type in and call out f of a particular x value. For example, I can make up an x value, 2.5. So I can say f of 2.5, is that the same as g of 2.5? So if these two functions are equivalent, numerically, they should show equivalence as well. I do not pick values that might lead me to a false positive here, like a 0, 1, 2, and also any domain restrictions, because again, these two functions are equivalent, but one has a whole or removable discontinuity and one does not. So in order for me to see that they're numerically equivalent, I just choose a random value that's not a domain restriction. If I factored this incorrectly, because a lot of us accidentally factor the sum of cubes like this, and we say, oh, it's x plus 3 quantity cubed over that original x plus 3. What I can see is that these two graphs do not trace each other. Now f and g are not equivalent graphically. They don't trace each other. They're also not equivalent numerically anymore. So I can see that f is not equal to g. So my algebraic rewrite, and notice I haven't even divided those factors of x plus 3 out, but my algebraic rewrite is not correct. So I use Desmos a lot to check for equivalence, especially if I'm rewriting a function or just doing some algebra before I go to do my calculus. I just want to check my algebraic rewrite. These are not equivalent, so that would not have been how we did it. So our answer of x squared minus 3x plus 9, I'll just put it over 1, that does trace, so that is an equivalent rewrite. Again, for all values except for that domain restriction that just shows me where the hole might be. So I hope you found this quick video on how to use Desmos helpful. It's a really great, useful tool when checking our algebra. So thanks for watching.